Assalamualaikum, welcome to my YouTube channel. In previous video I discussed two classifications that are Dobrynin trait and Newland's law of octaves. In this video I'll discuss Lauder-Meyer classification and Mendeleev's periodic law and periodic table. So let's start. In Newland's law of octaves, the periodic arrangement of elements didn't include noble gases because they were not discovered then, and the behavior elements couldn't also be accommodated. So that's why another attempt was made to classify elements. A German chemist, Lauder-Meyer, published an incomplete periodic table in a book in 1864, and he extended it in 1869 to include 56 elements arranged in groups from group 1 to group 8. Further, to bring in light the concept of chemical periodicity, Lauder-Meyer plotted the values of certain physical properties such as atomic volumes against atomic weights and obtained different curves. He observed that elements with similar physical properties occupied similar position in the graph. So let's see. For example, alkali metals occupy the peaks of the curves, and the halogens and elements forming acidic oxides occur on the ascending portion of the curves. He arranged the values and obtained a graph that is as shown in board. So the peaks you can see are obtained from the elements lithium, sodium, potassium, rubidium and cesium. So they have similar properties and occupy same position on the graph. And same is true for the rest of elements. And these 7 are 7 groups. Periods. As I show on the curve with dots, the rest of elements exist there. On y-axis atomic volumes and x-axis atomic weights. Lauder-Meyer classification couldn't receive proper attention. There may be two reasons for this. Let's discuss them. It was incomplete as compared with Mendeleev's periodic table, which was published in the same year with remarkable predictions of discoveries of certain elements. The second may be Meyer's classification was supported by a study of various physical properties such as atomic volumes, malleability, brittleness, and electrochemical behavior related with atomic weights with no empirical or logical basis of classification, as we find in Mendeleev's periodic classification, which is entirely based on periodic law. So this is all about Lauder-Meyer classification. Now I am moving forward to Mendeleev's periodic table and Mendeleev's periodic law. In the year 1869, Mendeleev, mainly on the basis of physical and chemical properties, discovered empirically a law known as periodic law, which he stated as the properties of the elements are periodic function of their atomic weights. This is a simple and basic statement of this law. Mendeleev's law is an extension of Newland's law of octave. Although there was no fundamental basis for the periodic law due to the lack of knowledge about the atomic structure or atomic numbers, yet the classification of elements on the basis of periodic law proved useful for predicting unknown elements and for establishing a relation between chemical properties and atomic weights. Mendeleev arranged all the then known elements in order of their increasing atomic weights in 7 horizontal lines called periods and in 8 vertical columns called groups. The horizontal lines are periods and vertical columns are groups. It is felt that in certain cases Mendeleev himself disregarded the periodic law. Now let's discuss Mendeleev's periodic law. Periodic table. I'm not going to discuss each and every element, but I'm just trying to give concept of this law. It is felt that in certain cases Mendeleev himself disregarded the periodic law. For instance, he placed argon 39 before potassium 39, argon 39.9 and before potassium 39. This fulfilled the real objective of classification, that is to put together those elements which resemble and to separate which differ in properties. Mendeleev left certain gaps in his periodic table for the elements to be discovered. According to his prediction, he named them as Eka-boron, Eka-boron, Eka-aluminium, and Eka-silicon. He also predicted the atomic weights and properties of undiscovered elements. These elements were discovered in the life of Mendeleev and were named scandium, gallium, germanium. Further, these elements were found to possess properties as were predicted by Mendeleev. In the remaining columns, as you can see on the board, all the rest of elements are arranged. You can see in textbooks or on internet. I am not going to write each and every element on the board. That was just the introduction to the Mendeleev periodic law. So this is all about today's lecture. In next lecture we'll discuss modern periodic law and periodic table. Till then, Allah Hafiz.